Okay, this recording is the rest of Unit P4 for Algebra 2 Honors. It'll be posted on my website. I'm going to go through pretty quick. Okay, the first thing we have here, we have a difference of cubes. So if you look at your formulas that I had you copy down, you could see the pattern for that. I'm going to show you really quickly here how to do that. You can see x to the third is a perfect cube. 27 is a perfect cube. So the way that you do this is you start with a binomial. In that binomial, you should take the cubed root of each term. The cubed root of x cubed is x. The cubed root of negative 27 is negative 3. Okay? Then you're also going to have a trinomial. In that trinomial, what you're going to do is square the first term from the binomial just right, so x squared. Then you're going to multiply the two terms together and use the opposite sign. So you have x times negative 3 is negative 3x. Use the opposite sign to make that positive 3x. And then you're going to just square the last term. So that gives you 9. So x cubed minus 27 is x minus 3 times the quantity x squared plus 3x plus 9. Notice that middle term on the trinomial is not doubled. So it's different than the formula for when we squared a binomial. All right, similar manner, letter B here, they're both perfect cubes. Z cubed is z to the third. 125 is 5 to the third. So we start with a binomial, take the cubed root of each. Cubed root of z cubed is z. Cubed root of positive 125 is positive 5. Okay, then again with the trinomial, square the first term that you just wrote. Multiply the two terms together from the binomial and change the sign. So take the opposite, so negative 5z, and square the last term that we just wrote, so 25. Okay, we have one more just like that. It's also a perfect cube because 27 is 3 cubed, x cubed is x to the third, and 8 is 2 to the third. So we'll start off the same way. Take the cubed root of the first term is 3x. Cubed root of the second term is positive 2. All right, and then for the trinomial, square the first one, 9x squared. Multiply the two together and change the sign, so negative 6x, and square the second one, so that's plus 4. All right, so that's your sum and difference of cubes. The next thing we're going to do is factor things that have 4 terms. If you remember in your notes, I had you write the box that had 4 spaces in it, kind of like a Punnett square that you might have done in biology. Okay, what we're going to do is we're going to write in those boxes, we're going to write the 4 terms that we have there in order. So x to the third goes in the top left, 5x squared goes in the top right, negative 5x goes on the bottom left, negative 25 goes in the bottom right. Okay, then we're going to go across the rows and across the columns to factor out any common factors, any greatest common factor. So if I'm looking along the first row here, those two terms that I just underlined in green, they both have an x squared in common, so I'll factor out that x squared. If I go along the bottom row, they both have a negative 5 in common, so I'm going to write negative 5 here. Next, I'm going to go do the column. So the two boxes on the left, they both have an x in common. And then I'm going to do the column on the right. That would have a 5 in common. All right. So I actually have it factored now. I just need to write it down as x plus 5, which I just got from here at the top, and x squared minus 5, which I got from here along the left. Okay, going to do the same thing with letter B. Start with the 4 boxes. X to the fifth, 2x to the third, x squared, and 2. First row, I can factor out an x to the third. Second row, there's nothing in common, so I'm going to write a 1. First column, I can factor out an x squared. And the last column, I could factor out a 2. All right, this one's going to be slightly different, and you'll see why in a second. Sorry about that. When I write them down, I have x squared plus 2 and x cubed plus 1. Okay, that's the same as the previous one. But if you notice, the binomial on the right, that is a sum of cubes. X to the third is x cubed. 1 is 1 cubed, so I have to break that down further. I'm going to copy the first one down, and then I'm going to follow what we did on the top of the page. So I start with the cubed root of x cubed is x. The cubed root of positive 1 is plus 1. And then I have to do the binomial, where I square the first term, multiply the two terms together and change the sign, so that's negative 1x, or just negative x, and then square the last term. And now that is completely factored. All right, we'll switch to the next page. The next page is just practicing a variety of factoring. So we've covered all of the types. Now we're just going to mix them up. First thing to always look for is a GCF. If you look at this first one, we could factor out a 6. That would leave us with x squared minus 9. X squared minus 9 is a difference of two squares, so you can factor that into conjugate pairs. So that would give you x plus 3, x minus 3 when you take the square root of each of those two terms. Then we move on to the next term, or the next problem, b. All right, b, it's a grouped difference of two squares. This first term is a perfect square because it's squared. The second term is 7 squared. So again, I can break that down into t minus 1 plus 7, t minus 1 minus 7. In each of those big parentheses, I'm going to combine my like terms so that it gives me t plus 6 for the first one and t minus 8 for the second one. We move on to the next problem. All right, here we can factor out a 5. That will leave us with x cubed plus 8. X cubed plus 8 again, sum of cubes. So bring down the 5. Sum of cubes, take the cube root of each, so x plus 2. Then start a trinomial where you square the first one, multiply the two terms together, and double them, or not double them, change the sign, so minus 2x, and then square the last term. So that's plus 4. All right, if we look at letter D kind of looks like a big old mess. It's not. It's actually two big terms. I just underlined the first term. Now I'm going to underline the second term. All right, what they have in common. You can see they both have a 3x plus 2 and a 1 minus x. You want to take the one with the smaller power. So for the 3x plus 2, the one on the right has the smaller power. That's just the first power. Okay, for the 1 minus x, the group on the left has the smaller power. That's second power there. All right, and again, anytime that you pull out a common factor, you're going to divide by that common factor. We're going to divide all those terms. So let me write this down. Okay, you can see in the first one, the 3x plus 2 on the denominator cancels with one of the ones in the numerator. The 1 minus x quantity squared cancels with all of the ones in the numerator. On the other term, other big term, you have 3x plus 2 to the first, cancels with 3x plus 2 to the first. 1 minus x quantity to the second cancels with two of these three, leaving us with only one. All right, so what I have left on the left side is 7, then 3x plus 2 to the first, and then plus, let me put a bracket in here, 1 minus x. All right, inside that bracket, I can combine some like terms and distribute a little bit. So I'm going to copy the rest of it down, 3x plus 2, 1 minus x, quantity squared. All right, when I distribute, I get 21x plus 14. Then I have the plus 1 minus x, so that gives me 20x plus 15. All right, if you look at that last term, you can factor out a 5, and since we're factoring, we want to make sure we do that. So I'm going to move that 5 all the way out front. And since I'm factoring the 5 out, I'm going to divide each of those by 5. The other two terms I'm going to copy down, or the other two binomials I'm going to copy down. 1 minus x quantity squared, and this becomes 4x plus 3, and there's our answer. Okay, so it looked a lot more complicated than it was. It wasn't actually terribly bad. Okay, you got to look for those groups that you can pull out together. Okay, and that is it.